Okay, organic halids 1.4. So halogen group, you know, is gonna be Cl, Fi, those in the last group, the second last group, right? So let's say you have hydrocarbon, the 2Cl is attached on a carbon. How do you name it? And a first carbon and second carbon, you have chloro. It's gonna be di, 1,2 dichloro, and the main chain is ethane because this is alkane. You already know the naming here. Draw the structure diagram for tribromo 5-methylhexane. So knowing that hexane is 6, so in the main chain you have 6 carbon. On a second one, and again on a second one, and on a fifth one, you have bromo. It's 3 of them. So you put Br here, and Br here. 5-methyl. On a fifth carbon here, you have methyl. Methyl has a 1 carbon. Then you need to put a hydrogen. Here it has a 1 bond. You need to have 3 more hydrogen. Because around the carbon, you need to have totally 4. Here it is 4 bond around C. It's good. Here 1 bond, so you need to have 3 here. It has 2 bond around C here. You need 2 more hydrogen to make 4 bond. Is again, you need 2 hydrogen here. Same reason. It's 4 bond around carbon here, and here you need to have 3 hydrogen. Any question? So you already knew how to do this, perhaps. Write the IUPAC name of that. So how do we do that? So we know that how many carbon is there? 1, 2, 3, 4, 5, 6, 7 carbon. And now this Cl is belong to this one or that? Of course, this belong to this. Why? Because it has 1 hydrogen. It has 2 hydrogen. True. So if you just open that, this is connected to the C, and it just have 1 hydrogen that is connected to another C, right? So it need to have a Cl here versus this one just had 2 hydrogen and it's good, right? So it means this Cl is that. So on 1, 2, 3, 4, the 4th carbon, you have Cl. 5, 7, 7 one you have Br, but from where to where we count, we count from the side that give me lower number. Perhaps I count from here. 1, 2. On the second carbon, we have Br, 3, 4. On a 4th carbon, I have Cl. There's going to be 2 bromo, 4 chloro, heptane, because you have a 7 carbon in the main chain. Any question?
No.
Now here, 1, 2 dichlorobenzene. Benzene ring, you already know. This is the benzene ring when every other bound is a double bond. On the first one, 1, 2. On the first one, on the second one, you have a color. Say dicolor, 1, 2 dicolor. So it's a color here. But make sure when you draw that and you want to show that, you just put a circle here. Make sure that, it's this 1, 2, 3 bound around carbon. So you need 1 bond for Cl. Of course, you have hydrogen, 1 hydrogen at these edges, but we don't need to use to do it. When you put the circle here, means it is other type of drawing it. Any question?
No.
Now practice question. I want you to do question number 1, 2. This is page 33. Properties of organic halids. Okay, looking at this table, hydrocarbons at CH4, C2H6, it's getting bigger and bigger as the boiling point is increasing. They are not polar. When there's no polar, the only force is van der Waals, right? London force. London force depends on how many electron proton you have. Bigger or higher amount of electron proton, the a London force is increasing. So of course, C4H10 compared to CH4 is bigger, has higher amount of electron proton. The London force gonna be bigger here. That's why the boiling point, the intermolecular force is gonna be bigger here, right? That's why they attract each other. It's harder to take them apart compared and you have a lower intermolecular force. That's why I see the boiling point is increasing. This amount of energy you need to take them apart for C4H10 is bigger than CH4. Same thing when you have alkyl one. I know it's polar, but again, because it's become bigger, so but boiling point gonna increase, same pattern. So here is preparing organic halids. Now, how do we prepare the organic halide like that? So here is ethyne, it's triple bound. If you reacted with boromine, the triple bond will break. So that bond here will break. Now C need to have a bound, C need to have a bound here. One of the Br comes there and one of the Br comes here. And then I have 1,2-dibromoethene because you have a still double bond. Any question?
No.
So next one is, now I get the product that I got there and I reacted with Br2 again. Now the double bond gonna break and it need a bound with Br and it need the bound with another one. So Br come here, Br come here. As you see, is 1, 1, 2, 2 tetra. Tetra means 4. Tetrabromoethane. Any question?
No.
Now here's a benzene ring with Cl2. You know there is a hydrogen at each edge of this carbon. This is carbon, and you have a hydrogen here. You have hydrogen at the other places. I'll just show it one. But this hydrogen will be substituted by that. So, and then you have the benzene ring with the Cl and HCl as a product. So preparing alkenes from alkyl halides. So here is OH. OH, it could be NaOH, right? But I'm just showing, say in exam, I could give you what is the product of this hydrocarbon reacting with NaOH. You need to know NaOH is a strong base, so it would be in ion form. So basically this plus OH. What is happening, one of these hydrogens will, 2 hydrogen, exactly. 2 hydrogen will come out and okay, sorry. This is the reverse. See, we have a 2-bromopropane. So this Br will get out because I need to have a double bond now. This H need to get out too, right? So these two need to get out. The hydrogen with OH will give you water and the Br will come out. So this is kind of the reverse. Yeah. Any question?
No.
You call it elimination reaction. Is alkyl halides, when it's halide is halogen attached to hydrocarbon. A plus OH, which is hydroxide ion, will give you the alkene double bound, water and the ion. This is elimination. So what question you do? This is page 37. You do question number 6 for me. Okay.